Alright, so welcome back. In our last video, we solved our system of equations using the graphing method. In this one, which, if we're going to be honest, is much easier either if they provide you with the graph or if you get to use a graphing calculator, which if you have one, I'm happy to show you how to use it. Example 2, we're going to go over how we can use the elimination method. So we're talking about attendance at Pool A and Pool B. When we look at our question, it says on what days was attendance the same for both pools. So we want to know what days, that would be our Y, and what was the attendance. Sorry, I got that mixed up. Days would be the X, time is always our X variable, and what the attendance was is our Y. So we're trying to find our X and our Y. Now to use the elimination, remember that if we're wanting to do any factoring, which is, or actually any of our methods of solving a quadratic, we need to have it set equal to 0. So where we have these both being Y is what we would want to get rid of. Partly because, and I'm going to rewrite this, I'm going to write it with Pool B up above. Because I can't get rid of X easily without also having to create an X squared in my linear equation, which is impossible. So when we're doing a linear with a quadratic, we will always go for eliminating the Y. And so in order to do that, we're going to multiply the bottom by a -1. So now I have Y equals a negative X squared plus 39X plus 64. And we're going to add to it negative Y equals a negative 28X minus 4. So now we combine these. Our Y's go away and we get 0. Our negative X squared comes down. 39 minus 28 is 11x, so we get a plus 11x, and 60 minus 4 is 60. Now, from here, I'm going to at least attempt to factor if I can. What I am going to do is I am going to factor out a negative real quick, so we're going to take that -1 out, so that we have x squared minus 11x minus 60. So I'm going for, find myself a little scratch area. Maybe if I can figure out where my pen went. There it is. We want -60, so we want numbers that multiply to 60. So I know I've got 6 and 10, and I've got to subtract to 11. 6 minus 10 is not going to give me a -11. I can do 3 and 20, but that's too big of a difference. We could do 5 and 12, but 12 minus 5 doesn't give me 11. So I'm going to continue. I've got 2 and 30, still too big. 4 and 15 gets me to 60, and 15 minus 4 gives me 11. So to get a -11, that means I need a -15. So there's my two factors. Because it is a 1 in front, I am going, so right now I still have that -1 times. When I put my two sets of parentheses here, I am going to make this x plus 4 and x minus 15. And then we just need to finish solving. So I'm going to set everything equal to 0. The -1 doesn't get us anything when I set it equal to 0, but x plus 4 equals 0 and x minus 15 equals 0. We finish solving these. We get x equals -4 and x equals 15. Now, when we're talking about this, x is my number of days. I'm not going back in time, right? So I can't have the -4, which means it takes 15 days for them to be the same. And then from here, I just need to solve for y. The easiest one to plug into is Pool A, y will equal 28 times 15 plus 4. Again, just like before, you could plug into either equation. It's just the linear one means I don't have to square anything. And it has less negatives when I use the original. So this one's just simpler. So we're going to take 28 times 15 and get 420. And you add 4. And so our attendance that day was 424 people. So 15 days, 424 people. And that's how we figure it out. That is it. Again, we just multiplied, in this case, by a -1 so we can get rid of the y's. And I'm going to assume it's going to be that simple for you each time on your Math Excel. If it's not, come see me. In the next video, we'll go over how to use substitution method. And until then, stay classy.